A very good day to both panelists, technologist Dr. Farina and Dr. Nabiha. So today my presentation is all about enhanced switching control for grid-tied single-phase square wave inverter using FPGA, which was supervised by Dr. Afrorazi bin Abu Bakar and also Professor Madi Dr. Vayu Mulya Uttam. So let me introduce myself. Name given was Tharnisha Sithananthan, and currently I'm pursuing Masters of Electrical Engineering by Research in UTHM. So without further delay, the topics covered in this presentation is as shown. First of all, the introduction shows that the integration of renewable energy sources such as solar and wind with the electrical grid are less stable due to the intermittent nature of renewable energy sources. Thus, the system requires grid synchronization and better power quality, which may be achieved by the implementation of appropriate control techniques and algorithms. So a fast response is required during synchronization to detect sudden changes in the grid, especially during an unbalanced load to produce a smoother output with lower distortions such as in V2G technology, and also by the development of fast DSP such as FPGAs and solid state switching device technologies. So PWM algorithms have been created to provide the PWM signals for microcontroller systems in real time using digital processing. So with the PWM techniques, in its simplest form, generates an on and off signals to activate a switch to allow current to flow through a circuit, and also using an analog to digital controller. So in order to achieve the grid synchronization, grid-connected inverters face several challenges, mainly the mismatch in voltage amplitude, frequency, and also phase angle, as well as the grid voltage disturbances and also grid faults. So also there are issues of out-of-phase signals due to the phase shift introduced by the passive components that are represented in the filter circuitry. So these problems not only reduce the overall efficiency of the system but also results in the power quality that is less than ideal and also has the undesired levels of THDs. So besides that, the conventional methods of calculation to achieve the suitable algorithms for grid synchronization are less efficient. They opt more time, and which is also is quite complex. Thus, the performance of single-phase full-bridge inverters can be considered improved by combining the advanced digital controllers and also with the HDL-based designs. So the objective of this research are to develop a controllable switching signals using PWM technique for single-phase full-bridge inverter circuitry, and also to improve the efficiency of the proposed system by designing and enhancing fast response switching based on digital PLL for single-phase full-bridge inverter. And finally is to analyze the performance of the proposed fast response switching methods in terms of response time and also THD. So while the scope of the research are mainly focused on the software for the circuit development, which is MATLAB and Cortex-2, the microcontroller used in this project was Altera DE270 board, and also the similar parameters are used for simulation and also the hardware prototypes. Moreover, the research gap was figured out by comparing the proposed research with previous research based on system performance and application methods. So in this research, the main controller implemented was FPGA, at where the control structure developed was SRF, since it was crucial to align the reference signal with the grid signal so that the current fed into the grid could be precisely regulated. So the significant difference between the earlier studies and also this research was the digital implementation based on the FPGA to generate the square wave switching signals with third harmonic elimination for the full bridge inverter for a faster response. Thus, the contribution of this research is developing an enhanced fast response switching scheme to ensure the system responds ultimately in the next half cycle. So the proposed system was developed to overcome issues such as mismatched voltage amplitude, phase angle, and frequency in grid synchronization, and also achieve the response in half cycle and responding quicker to the changes. So in this proposed system, the key components were a single phase full bridge inverter, a ZCD, gate driver units, FPGA, which is as the controller, LC filter circuitry, and also two types of transformers, which are isolation transformer and also step transformer. So the design algorithms flowchart for producing the synchronized signal based on ZCD integrated PLL are as shown. So the ZCD output operation circuit generates a high signal of 1 and also low signal of 0 for sinusoidal waveforms. And also based on the ZCD output that transmitted a signal to the FPGA board input used for the inverter gate operation. So the chosen FPGA board will emit digitalized signals for either positive or negative sinusoidal waveforms. The software involved in the research were MATLAB Simulink and Quartus 2 as shown. So the MATLAB Simulink software was used in initial design stage of modeling the circuitry, and also the coding of the proposed system algorithm was developed using Quartus 2. Besides that, the components used in this development of this proposed system are as shown. We have isolation transformer, FPGA board, gate drivers that are transformer, LC filter, single phase full wave inverter, and also ZCD. So these are the results section. By the results section, we can see that the single phase full wave inverter consists of 4 switching devices to ensure a bidirectional power flow for high quality power conversion. The switching signals are acquired from the software simulation and also experimental analysis as well. So the switching signals were measured from each MOSFET's gate signal output in the inverter circuitry. So these are the results obtained for the unfiltered and also filtered signal as well. So we can see here if the unfiltered inverter output was in phase with the grid voltage, that indicates both the signals are operating at same frequency as well as the peaks and the zero crossing of the signals. So the single phase full bridge inverter was then tied to the LC filter to produce a smooth sinusoidal waveform. So from the result, we can see that the passive components in the filter produces phase lag in the generator output waveform, where the measured lag was of alpha 30 degrees, meaning that the signal was out of phase with the grid signal, which can be described as a resultant signal lagging behind the grid signal by 30 degrees. So a control strategy was associated in the digital PLL to mitigate the phase lag and also uphold a precise correlation between the grid and also generated output waveform. So the generated waveform and the grid waveform after adjusting the phase angle in the digital PLL is as shown. So it is clearly shown that the generator voltage was now in phase with grid voltage. Next, the THD analysis for voltage and current showed that both the harmonics has been significantly decreased after implementing the filtering component. So the decrease in harmonics was mainly contributed by the third harmonic elimination. So by the end of research work, the expected outcome is to develop a controllable switching signal using PWM technique for single phase full bridge inverter circuit, and also in terms of phase angle, frequency, and also voltage amplitude. Also, the research focused on the performance analysis for the fast response switching method in terms of response time and also in terms of reduced THD of the filtered signal. So that's all from me. Thank you.